Good afternoon, everybody. Welcome to a Tuesday afternoon, the last week of summer term for Chem 170 with your host, me, Dr. White. And things are almost done. A couple things. Tomorrow, I will go through test number 4 answers sometime today before I go to sleep. I'll grade it and I'll try and get the points out to you either today or early tomorrow morning. Also, stop by. Yep, I got the message. It's already, I'll get it done if by, hold on. All right. Important things. Thursday, I will be giving the final exam. And you're welcome. I will be giving the final exam. Now, tomorrow, if you can make it, come by. So I got a special surprise that I'm going to cut out of the video because I don't want it in the video that you'll want to see. It really will be special. And let's get going. Also, I'll be doing today's lab. So we got a lot to do. I better get going. Yesterday, I finished up with thiols. Let's talk about ethers. Ethers are I get the tip off or the cap off. Ethers have this function as an ether. How do you make it? The Williamson ether synthesis. An alkoxide reacts with an alkyl halide. The X here is chlorine, bromine, or iodine, form an ether plus a salt. The bond from the oxygen here goes to the carbon with the halogen. And that's where this is. So let's try one. And the question is, give the organic product or products to the following. Your turn. And when you're done, give me a thumbs up. Hint, Jordan, take your time. All right, let's do this. What do we have that's different? Ooh, oxygen minus charge, sodium cation, R group, alkoxide. What's different here? Carbon with a halogen and alkyl halide. And X can be chlorine, bromine, or in this case, it is iodine. And when you react it, you form an ether plus salt, but I asked for the organic product. Here's R prime. Notice the carbon here with the halogen. First of all, you have R group O, and then the carbon with the halogen is the center of 2, and this is a product you get. And that's how you do ethers. Now, I talked about epoxides, and I talked mainly about ethylene oxide. On the final, I'll never ask you what's the name of this compound, but I used it in class, so I showed it to you. Now, if you take an alcohol with a 1 molecule of ethylene oxide, you get this ether alcohol. Now, if you take an alcohol and react with N moles of this epoxide, ethylene oxide, you get a polyether alcohol that has a structure. Common mistake, students put the hydroxyl inside the bracket. No, it goes on the outside. Your turn. Give the product or products, organic product or products for the following reaction. And since you may not have memorized all these general reactions, you should, but you may not, I'll help you out. And there's my help you out right today. All right, let's do this. What's different? Ooh, an oxygen with a hydrogen and a carbon. That's an alcohol. What's my R group? Ethyl. Ooh, 7 ethylene oxide, N is 7, and we get this polyether alcohol. What's our ethyl? Then O, CH2, CH2, close bracket. What's N? The coefficient here. In this case, it's 7. And then I'll have my hydroxyl group outside the bracket, and that's the molecule you get. Now, let's talk about ketones and aldehydes. Aldehyde, carbon double bond to oxygen with a hydrogen R group on it, aldehyde. How do you name that? Find the longest chain with, remember, this is a carbonyl carbon. I taught you that in this chapter. And you name it as an alkane, drop the E, add Al, no number. The carbonyl carbon is always number 1 in an aldehyde. You can't have them in a ring. And the rest of the substituents you do the same way. For a ketone, what do you have? You have a carbonyl, R group, and R prime. And for cyclic or acyclic, find the longest chain with the carbonyl carbon or the ring, name it as an alkane or cycloalkane, drop the E, add ONE. For a number, for acyclic, not in a ring, you need a number. Which carbon? And guess the lowest number is the carbonyl carbon. For a ring, no number, because the carbonyl carbon is always number 1. Now, I asked you to know 2 common names. One is when R in an aldehyde is H, that's formaldehyde. When in a simple as ketone, when R and R prime are methyl, that's acetone. Remember acetone, nail polish remover. Now, one of the most important things to me in organic chemistry, it's in red, you know it's important, is the carbonyl group. And as you know, on test number 2, you should know, how do you write the carbonyl group? Carbon double bond oxygen. How do you describe it with words? Carbonyl group. Carbon atom double bonds to an oxygen atom. Now, how do you make a aldehyde? Oxidize a primary alcohol. If you oxidize a secondary alcohol, you get a ketone. Now, a neat way to make a aromatic ketone is if you take and react benzene with an acid chloride, that's carbonyl with a chlorine in an R group, aluminum trichloride, you make an aromatic ketone. And the question is, what's the product or products for that reaction? And since you may not have studied yet for the final, I hope you are the next couple of days, let me help you out. And while you do that, I gotta go blow my nose and get some Kleenex. I'll be right back. I'm back. Everybody done? Give me a thumbs up if you're done. All right, let's take a look at this. Benzene ring, carbonyl, chlorine, R group. And that's an acid chloride. And what do you get? Oh, I forgot to put the product there, sorry. An aromatic ketone. So you got a benzene ring. Don't forget the bonds in the ring. Otherwise, that's cyclohexane. I mark it wrong. R is a T-butyl. And that's what you get. Now, bunch of reactions which we practice a lot in class. You can go back and look at the video. You take an aldehyde or ketone, react it with alcohol plus acid, you get a hemiacetal, hemiketal. If R prime is hydrogen, aldehyde. If R prime is carbons, ketone. Keep your eye always on the carbonyl carbon because that's where the fun is. If you take an alcohol or aldehyde or ketone plus 2 alcohols and an acid catalyst, you'll get an acetal or ketal. Again, keep your eye on the carbonyl carbon. Now, a special case is this, where the two alcohols are in the same molecule, ethylene glycol, and students forget this bond right here, don't. Now, once you have a hemiacetal, you can add acid and water, and you get back the aldehyde or ketone plus the alcohol you would have used to make that hemiacetal or hemiketal. Now, if you have a hemiacetal, you react it with acid or ketone. Yeah, I'm getting my hemi and regular mixed up. All right, if you have a acetal or ketal, and both of these give the same product, and the key is carbon with two oxygens single bonded to it. Carbon with two oxygens single bonded to it. And here we have, get back to the aldehyde or ketone plus the alcohol you would have used to make that. All right, let's move on. If we have an alkyl halide reacted with magnesium, you make the Grignard. And the Grignard reagent is so wonderful to use because it allows you to make carbon-carbon single bonds. And here's a reaction where if you take an aldehyde or ketone, react it with a Grignard, acid, and water, keep your eye on the carbonyl carbon, that becomes an alcohol, and you make a carbon-carbon single bond. Very special, very rare in organic chemistry. And something I think you should practice. Now, in case you didn't remember the reaction, I'll help you out. Keep your eye on the carbonyl. What's attached to that? Our prime or hydrogen. Our double prime stays there. It opens up to an alcohol. And from this, you make a carbon-carbon single bond. And remember, X can be chlorine, bromine, or iodine. And it's your turn. What would be the product or products for that reaction? 3 points each. All right. By the way, Jordan, hint, know this reaction. All right, what do we have? We have a ketone. Our prime is ethyl. Our double prime is methyl. Ooh, carbon, magnesium halide, a Grignard. And what's our triple prime? That. So keep your eye on the carbonyl carbon. What's attached to it? Our prime, 2 carbons, ethyl, and a methyl. And then I'll have an alcohol, because that's what this shows me. And then to my R triple prime, I have 3 carbons. And remember, your friend is always 4 bonds to carbon. And that's how you do it. And you made a really complex molecule. All right, a simple one, and that is if you take a ketone or aldehyde, react with hydrogen and catalyst. Catalyst can be nickel, platinum, or palladium. You break the pi bond, and each atom of the double bond carbon hydrogen gets a hydrogen, you made an alcohol from a ketone or aldehyde. Now, hydrogen can react with a carbon-carbon double bond. So someone found, and that's someone, I'm not sure who did lithium aluminum hydride. Wait, I am sure. It's H.C. Brown. And he came up with this reaction, and it does the same thing, but this one touches carbon-carbon double bond, but carbon-oxygen, break the pi bond, each atom of the double bond gets a hydrogen. Now, the last reaction here, aldol condensation. Remember, base here reacts with the hydrogens on the alpha carbon to make an enolate anion that attacks the other aldehyde and forms a carbon-carbon single bond. And you form a much more complex molecule, aldol, aldehyde alcohol. And with that, we're done with aldehydes and ketones. Any questions on this? Well, let's move on. And if we look, and now we have test number 3 review. Don't forget, these files are available to you in D2L. And here we have a carboxylic acid, carbonyl hydroxyl group, R group. How do you name it? Find the longest chain with the carbonyl carbon, name it as an alkane. Drop the E, hold on, let me make this a little better, bigger. And add OIC in the word acid. Now, if you have alkyl groups on the R, remember the carbonyl carbon is always number 1, but we don't write that in the name. Now, there are 3 common names, or 2 common, 1 actually common / IUPAC I asked you to learn. Acetic acid is when our group is a methyl. Anybody happen to pick up a bottle of vinegar and say, aha, it has acetic acid in it, and that's a carboxylic acid? Did you happen to pick up a bottle of ketchup, mustard, or relish, or pickles? It's got vinegar. Vinegar has acetic acid in it, and it's a carboxylic acid. Now, when R is H, that's formic acid. That water heated up is the defensive weapon of the fire ant. When R is a benzene ring, the people at IUPAC said, wow, these organic chemists have been calling that benzoic acid for eons. We can't change them, so we'll call it benzoic acid too. Now, if you have a carboxylic acid reacted with base, you will get a carboxylate anion. M here can be lithium, sodium, or potassium. Now, hint, when you take a carboxylic acid and react it with sodium bicarbonate, baking powder, you get the carboxylate anion, but the carbonic acid form breaks down to water and CO2. The arrow tells you it's a gas. Remember the little rocket ship. Also remember how I talked about my father's secret recipe for, not that secret, for really great tomato sauce. And 2 keys were, 1, near the end, put in some baking powder. And that neutralizes some of the citric acid in there from the tomatoes. The other one in a big pot, just put a little pinch of cinnamon, and that gives it that special professional taste. All right, how do you make a carboxylic acid? You take a primary alcohol and oxidize it, and we get a carboxylic acid. You can take an aldehyde and oxidize it, and guess what? You will get a carboxylic acid. Now, you know by now, Dr. White loves Grignard reactions with the Grignard reagent. And here's one. If you take a You take a alkyl halide, react it with carbon dioxide, second step acid and water, you will get a carboxylic acid that's 1 carbon longer than the R group you started with. And here's one for you to try. See, I'm sharing the fun once again. Give the organic product or products for the following reaction. Had a major paper fall out there. All right, let's do it. What do we see that's different? What's not carbon? What's not hydrogen? Carbon, magnesium halide, bromide, that's a Grignard. Carbon dioxide, second step, water and acid, and you get a carboxylic acid that's 1 carbon longer. So what's my R group? 2 carbons. Then I'll have a carbonyl hydroxyl group. And that's what you get. All right, let's go back to reactions. Now, next I started talking about esters. An ester is a carbonyl with an R group on it and an oxygen attached to that carbonyl that has R prime, other carbons. An ester, for the IUPAC names, you name the R prime as the alkyl group it is in front. Then one way, think of R prime as H, name it as a carboxylic acid, and then drop the IC in the word acid and add ATE. Now, B2, and what another student of mine came up with years ago, when R is not benzene ring, you can use B2. How do you do that? Name the alkane from the longest chain with the carbonyl carbon and drop the E and add OETE. And that's how you do it. I asked you to learn one common ester, and that's ethyl acetate, and that's this molecule. Remember, that's used as nail polish remover. Next, carboxylate anions. The reason I'm talking about nomenclature, because it's similar to esters. Next, how do you do it? You name M plus as the element it comes from in front, like lithium, sodium, or potassium. Then for the rest of the molecule, you'll name the carboxylic acid. If instead of O minus M plus, that was an H, you name that carboxylic acid, drop the IC to word acid, add OATE. Now, the same student for carboxylate anions like esters, name the alkane from the longest chain, including the carbonyl carbon, as an alkane, drop the E, add OATE. Now, how do you know the difference between a carboxylate anion and ester? Because both have OATE ending. Simple. If it starts with the name of an element, it's a carboxylate anion. If it starts with the name of an alkyl group, it's an ester. Now, you should know esters are responsible for the smell of most flowers and the taste and smell of many fruits and vegetables. Next time you taste or smell a banana or a red pepper or what's another, pineapple would do also, you're tasting esters. Next time you smell a rose, you're smelling esters. Now, how do you make esters? Take a carboxylic acid, react with an alcohol in the presence of acid, and you make an ester. And let's try that. Oops. In case you forgot, hopefully by Thursday you remember. That's how you make esters. Your turn. All right, let's get going. If we look here, what do we have? That's, oxygen double bond to carbon, hydroxy group on carbon. It's a carboxylic acid. Hydroxy group on carbon, alcohol, acid catalyst, you make an ester. What's my R group? That. What's my R prime? Isopropyl. So here's my carbonyl carbon. What's attached to it? Stays attached to it. What's my R group? The carbon in the alcohol with the hydroxyl group is the carbon bonded to the oxygen in the ester. So that's an isopropyl group. And that's how you do it. Now, once you have an ester, if you add acid and water, you get back the carboxylic acid and the alcohol you would have used to make that ester. If you have an ester and you use base, where M is lithium, sodium, or potassium, you get back not the carboxylic acid you would have used to make that ester, but the carboxylate anion of that carboxylic acid. Why? Because in base, this carboxylic acid becomes this carboxylate anion, but you do get the alcohol you would have used to make that. Now, next, if you take an ester and react with not one, but two molecules of Grignard, second step, acid and water, you get two alcohols. The first one, you made a two, not one, carbon-carbon single bonds to the carbon that was originally the carbonyl carbon of the ester. And then this part forms another alcohol. But you make not one, but two carbon-carbon single bonds. Hey, here's the reaction just to help you out. And there's something to help you out. All right, let's do this. If we look at this, what's different? Ooh, carbonyl, oxygen, carbons here and here. I have an ester. What's different here? Ooh, two carbon magnesium halide. I have a Grignard. Remember, X can be chlorine, bromine, or iodine. And what do you get? Two alcohols. I should have put a plus there. On the final, I will. And what's my R group? Methyl, R prime, methyl, R triple prime, ethyl. So keep your eye on the first carbonyl. That becomes this one right here. So my R group is methyl, carbon, OH, and my R triple prime, two of them, are ethyls. And my second alcohol, let's move me out of the picture here a little. What's our prime? Methyl. So you get methanol. And that's how you do esters. All right, any questions so far? All right, if I look at the clock, now is a good time to take a break, and then we'll come back and do amines. And I think we will get out early today because I'll also do the lab. So come back at 2:50 and we'll continue. I'm going to take a break. I'll see you in about 5.5 minutes, and 2:50, I'll be back. Let's get going. All right, let's get back to work. Now, let's talk about amines. Amines are derivatives made from ammonia, NH3, where you replace one of the R groups on one of the hydrogens with R group. And amines can be a primary amine, secondary, tertiary. I'll never ask that on the final, but when I discussed this, we used it. How do you name amines? Name each R group as the alkyl group it is, common name it that is, and then add the word amine at the end. Now, there's one amine I'd like you to know. When R is a benzene ring, we call that aniline. That's both the IUPAC and the common name. Now, something near and dear to my heart, and that's quaternary ammonium salts. A number of my patents use quaternary ammonium salts that I invented. And here you have 4 R groups on a nitrogen plus charge and an anion. And X can be chlorine, bromine, or iodine. How do you name a quaternary ammonium salt? Name each R group as the alkyl group it is in front and add the word ammonium halide. Now, oh, I just see a mistake here. Well, I'll get to that in a second. When X minus is bromine, Br minus, it's bromide, Cl minus chloride, I minus iodine. Now, amine salts are similar. And you name each R group and add ammonium halide. Now, note for amine salts, unlike quaternary ammonium salts, where R prime, R double prime, and R triple prime are all carbon alkyl groups, here in an amine salt, R prime and R double prime can be hydrogens. All right, let's take a look at this. How do you make a primary amine? React an alkyl halide with ammonia in the presence of base. Remember, amines, nitrogen can have 3 bonds to it. Amine salts and quaternary ammonium salts and nitrogen have 4. So unlike carbon, which is always 4, nitrogen can have 3 or 4 bonds. In amines, and I'll teach you later, amides, it's 3 bonds. In amine salts and quaternary ammonium salts, it's 4 bonds. Now, if you take an alkyl halide, ammonia in the presence of base, you'll get a primary amine. So let's try that. And the question is, what's the product or product? I'll help you out. Your turn. Give the organic product or products to the following. 3 points each. Thank you. All right. What do we have that's different? Chlorine on our group here. Remember, X here can be chlorine, bromine, or iodine. And now, do you break carbon-carbon single bonds? No. So I have 5 carbons I start with. I better end up with it. Now, this is important. The carbon with the halogen is the carbon that will be bonded to NH2. Placement is important. If you put the wrong carbon, I mark it wrong because that's not the right answer. And that's how you do it. And you made a primary amine. Now, if you take a primary amine, react with an alkyl halide base, you make a secondary amine. If you take a secondary amine, react with an alkyl halide, you make a tertiary amine. And remember, what you're seeing on the screen is available in D2L in the lecture folder, secretly named Test Number 3 Review. Now, if you have a nitrile, carbon-nitrogen triple bond, and reacted with excess hydrogen and a catalyst, remember, here you have 2 pi bonds, and each bond, pi bond, can be broken with hydrogen and catalyst. So 2 pi bonds, each atom of the triple bond gets 2 hydrogens, you make a primary amine. Oh, let's try that. Your turn. Give the organic product or product for the following. And give me a thumbs up when you're done. All right, let's take a look at this. What's different? What's not carbon? What's not hydrogen? Ooh, a nitrogen. What's not a carbon-carbon single bond? Right there. Triple bonds between carbon and nitrogen, nitrile. This is my R group. Another way of thinking of it, you start with 4 carbons, you better end up with 4 carbons. Here's my R group. This carbon here becomes this carbon here. So I'll put 2 hydrogens. Then I have my nitrogen, 2 hydrogens. And I know there are 4 bonds to carbon. And here's the product. Now, you could have written it this way. And notice on this carbon, there are 2 hydrogens. So I'll write it CH2. And a nitrogen, there are 2 hydrogens. I'll write that NH2. These are the same. Primary amine. Now, a reaction near and dear to my heart because it paid my mortgage, cars got me around the world. And that is, if you take a quaternary ammonium salt, I'm getting ahead of myself. Take a tertiary amine, alkyl halide, X can be chlorine, bromine, or iodine base, you make a quaternary ammonium salt. And remember, quaternary ammonium salts can be used as fabric softeners. Others are antimicrobial compounds, like in my mouthwash, and a whole lot of other things you can use it. They're also good for hair conditioners, but you know that. So let's take this one out for a run. And if we look at the reaction, I'm going to let you try this one first, and then I'll do it, but I helped you out with the general equation. All right, let's take a look at this. Now, remember, R sub T is a tallow group, and that comes from beef fat, yellow grease, white grease, and that means it's 18 or 16 carbons with or without a double bond. Now, what we really have here is a tertiary amine. I'll call this, notice there are two of them, R and R prime. The methyl group here, I'll call R double prime. Ooh, carbon with a halogen, alkyl halide, I'll call that R triple prime. So what do we get? Nitrogen. There are two R sub T. Now notice you have one methyl group and the other, the R double triple prime is a methyl. So I can write it like this. Because 1 + 1 is 2. What's the halogen? Chloride anion. You do not have to show charges. Now, you could have also written it this way. And there's other ways you could write it too, but these are the two most common. And that is dimethyl ammonium chloride. And for many years, that was the only molecule used as a fabric softener. I know I worked for one of the two companies in the world that made it. All right, now, amines are bases. You take an acid and react it with a base, amine base, you'll make the amine salt. And remember, R prime and R double prime can be hydrogen. Next, I talked about amides. And amides are carbonyl with a nitrogen on the carbonyl carbon. You have carbons. On the nitrogen, you have R prime and R double prime. And R prime and R double prime can be hydrogen, or they could be alkyl groups. Both or one could be hydrogen or none. And this is an amide. Now, quick public service announcement from Dr. White. Don't forget, when you're studying for the final, play that fun game. Circle and name the functional group, 2 points each. Really, you should practice that. All right, now, how do you make an amide? You take a carboxylic acid, react it with either ammonia, that's when R prime and R double prime are both hydrogen, or primary or secondary amine. And remember, R prime and R double prime can be hydrogen, and you get an amide. All right, your turn. What would be the product or product of the two compounds you get when you're reacting those two molecules? And when you're done, give me a thumbs up. Thank you. All right, what's different? Ooh, oxygens. Remember, look for what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Excuse me, because that should get your attention like this. Hopefully that got your attention. And we have a carboxylic acid. Carbon, carbon, carbon. Ooh, nitrogen. We have an amine. Now here, this is my R group. Now an amine, I can call this R prime, but one of the hydrogens here is my R double prime. And I form this amide. Look at the carbonyl carbon, this carbon, which becomes this carbon. What's attached to it, R, is still attached to it. Then I have a nitrogen, R prime, 3 carbons. The carbon with the nitrogen, the amine, is the carbon bonded to the nitrogen in the amide. And R prime is double prime is hydrogen, and that's the molecule. Now, if you switch the hydrogen, the N-propyl, that's fine. Now, reactions of amides. You take an amide, react it with acid and water. Remember, in your stomach, there's HCl, and this is how your stomach breaks down protein, which I'll cover tomorrow. And here we have an amide, acid, water. What do you get? You get back the carboxylic acid plus the amine? No, the amine salt of the amine you would have used to make that amide. Remember, amines are bases. As soon as you form it in the presence of acid, you form the amine salt. Remember, R and R prime can be hydrogen in amides. And now if you take an amide and react it with base and water, here you get now, not the carboxylic acid you would have used to make that amide, but the carboxylate anion of the carboxylic acid you would have used to make that amide. Why? Because base, NaOH, will react with a carboxylic acid to give you the carboxylate salt. Now, you do get the amine because amine's a base, and in base, it's unchanged. Now, the last thing I asked in this chapter was heterocyclic compounds. And you should know a heterocyclic compound is a compound with a ring, or a ring compound, with carbon atoms and other atoms such as oxygen, nitrogen. I asked you, the only one to learn is pyridine. Pyridine looks like benzene, except one of the carbons has been replaced with nitrogen. Now, tomorrow, I'll go through the answers to test 4, and I'll go through something. I won't do it today, but you should know, how does soap work? The other thing I'll go through right now is there are 3 things besides how soap works you should know leaving my class. The first one, how do you describe with words in a general reaction what happens when you eat a fat or oil? And in your stomach, there's acid and water, so it's acid hydrolysis. And what's the key functional group in a fat or oil? An ester. So it's acid hydrolysis of an ester. You should know how to describe words and a general reaction, which is, you learn for test number 3, ester, acid and water. You get back the carboxylic acid plus the alcohol you would have used to make that ester. That's how you describe with words and a general reaction, excuse me, if you eat something with a fat or oil. It's acid hydrolysis of an ester. And here's the general reaction. Ester, acid, water, got back to carboxylic acid and the alcohol you would have used to make that ester. Now, what happens when you eat something that's a carbohydrate? And you should be able to describe what happens in your stomach with words and a general reaction. Well, there's acid and water, and we call that acid hydrolysis. Now, what's the key functional group that holds glucose together in a starch, carbohydrate? And that is an acetal. Key functional group in carbohydrates, acetal linkage. And you learn for test 2, take an acetal or ketal, react it with acid and water. Keep your eye on the carbonyl carbon, or the carbon with 2 oxygens, comes the carbonyl carbon. You get the ketone or aldehyde you would have used to make that hemiacetal, and you get the alcohol you would have used. If you want to put 2 there, you don't have to, but I better finish the structure. And they're connected together in glucose. So when you eat a carbohydrate, you should know how to describe with words and a general reaction what happens. Well, general with words, acid hydrolysis of the functional group that holds glucose together and starches, carbohydrates, is an acetal. And here's the general reaction. Acetal, acid, and water, got back the aldehyde plus the alcohol you would have used to make that acetal or ketal. Now, the last one you should know is what happens in your stomach, and I'll come down here, when you eat something with protein in it. And here, again, it's acid hydrolysis of, and what's the key functional group that keeps amino acids together in a protein? An amide. And here, how do you describe it with words? Acid hydrolysis of an amide. The general reaction, amide. And now I'll use hydrochloric acid, which is what's in your stomach. You get back the carboxylic acid you would have used to make that amide, but you don't get the amine. In the presence of acid, you get the amine salt of the amine you would have used to make that. So eat a protein, key functional group that holds amino acids together in a protein amide, and you have acid hydrolysis of an amide. And here's the general reaction. So let's go through this again. Eat a fat or oil, key functional group ester. How do you describe that with words and a general reaction? Acid hydrolysis of an ester. Ester, acid, water, you get back the carboxylic acid and the alcohol you would have used to make that ester. When you eat a carbohydrate, what's the key functional group holding glucose together in starches or carbohydrates? And that is an acetal. And how do you describe with words and a general reaction what happens when you eat a carbohydrate? You have acid hydrolysis of an acetal. The general reaction, acetal or ketal, acid and water, get back to ketone or aldehyde plus the alcohol you would have used to make that acetal or ketal. And finally, when you eat a protein, what happens? How do you describe what happens in your stomach with words and a general reaction? And here, excuse me, we have, again, your stomach, water and acid. So that's acid hydrolysis, the key functional group in a protein, and amide. So it's acid hydrolysis of an amide. And here we have the general reaction you learned for test 3, amide, HCl and water, get back to carboxylic acid, and the amine, no, amines are basic in the presence of acid. You get back to carboxylic acid plus the amine salt of the amine you would have used to make that amide. All right, the best way to study for the final is use your hourly exams as practice problems. Also, go back and review the general reactions and nomenclature in the test reviews, which is why I made them, to help you. All right, any questions? It's time for lab, the last lab. Oh, that's sad. The semester's almost over. Well, first of all, I got to open it. All right, pay attention. It's going to go quick. Now, a lot of the labs you learn this semester, there are certain tests used before electronics, that electronic instrumentation we now use in organic chemistry, like infrared spectroscopy, nuclear magnetic resonance, to name a few, that help you identify functional groups. But long ago, like in the late 1800s, early 1900s, they didn't have that. So what if you had some food? Did it have a carbohydrate in there? More specifically, did it have a starch? And how did they determine that? They used a reagent. Originally, iodine would react with starch to give a dark blue color, so blue it almost looks black. Now, iodine is not soluble in water, so pay attention. Someone found out if you took iodine and reacted with potassium iodide, you get this potassium iodide, K plus I3. And this is now water soluble. Why? Because it's ionic, and water is ionic. And it's easier to put a solid to test something, or make a solution which you just put a few drops of that on here. Now this solution is a red-brown color. Now, interesting thing happens. When you have a long carbohydrate starch, it's not a straight line like I write it on the paper. It's more a helix, like this. And all along this, you have hydroxyl groups from the glucose. And this is in, like, look at a piece of bread. It's white, the bread. Or if you look at, I don't know, a potato, it's almost white. Now, if you react this with potassium iodine solution, which is called tincture of iodine, and they react the iodine with the potassium iodide to make this new compound, which is water soluble. This reacts in such a way, or interacts, and when the iodine 3 gets inside there, where this is red-brown, this inside there becomes a dark blue. So if you take a substance of food and you take a few drops, excuse me again, and put it on there, you wait 10 seconds, not even that long, but wait 10 seconds. If it stays red-brown, there's no starch. And by the way, I should have written here, and you need a very long chain of multiple glucose to have a starch here. And this happens, and this shows you there's a starch present. So this is a great way to test food back when they didn't know, is there starch in there or not? And now here's something for you to watch once the commercial's over.
I've been getting paid $1,000.
I don't care what you get paid. All right, did everybody see the YouTube on your screen right now? Thank you. Well, let me play it for you. This is quick, but it's
An
interesting.
important constituent of our daily food are carbohydrates, which we consume in the form of starch. Starch is a high-calorie food that converts to sugar during digestion. Starch is also produced by all green plants as an energy store. Today, we will conduct an experiment to test the presence of starch in potato, rice, sugar, and salt. For this, we will need iodine solution,
That's tincture of
which is
iodine.
yellow-brown in color. Note the change in the color of iodine as it is put on the rice and potato. Both turn the iodine blue-black. Put some iodine on the sugar cubes. The color does not change. Salt too does not change its color. This proves that sugar and salt do not contain starch, while the starch in rice and potato reacts with iodine to form a blue-black compound. Now, the reaction is because the blue-black color is basically the formation of polyiodide chains from the reaction of starch and iodine.
All right, everybody see the Carbohydrate Lab on your screen right now? Thank you. Now, if we're in the lab today, you would be testing, it's a real quick lab, you're in and out quick. Potato, you saw it on the video, dark blue. Bread, dark blue. I'm going to skip the cheese and come back to that. Flour, dark blue. Cereal, dark blue. Now, sugar and honey, brown. Why? Because those are not a long starch. Those are a disaccharide with fructose and glucose. And that won't change the color of the tincture of iodine. Now, cornstarch, hint, does have starch in it. It turned it dark blue. Now, let's go back to yellow cheese, white cheese. When we do this at ECC, Dr. White has to buy the cheese because the school doesn't have any, you can't get it from. I also, either I or other faculty bring in for me potato bread. We already got cereal, sugar we got there, honey we bought a long time ago, cornstarch we got there. Well, a number of years ago, I would bring in good cheese. And I happened to be in a grocery store. They had a sale on those single slices of the low, how should I say, inexpensive brand. So I brought it, students tested it, the yellow cheese, and it turned dark blue. What's going on? Cheese? That doesn't have carbohydrates. Well, it turned out that one did. You looked at the yellow cheese label, it had carbohydrates. That was filler to bring the price down. After that, I also bought some high quality white cheese, like Romano or like that. And that's high quality. There's no fillers. And that's why it stays red or brown, because there's no starch in it. Now, for this lab, please answer the questions at the back. And remember, this is the end of the semester. I need this lab by end of Wednesday, Friday morning at the latest, or you'll get 0 points. We got to get everything in this week. And with that, I'm done. I'm going to go grade your test number 4, so I can give it back to you and we can go through it tomorrow. And with that, I'm done for today. Gang gesund. Goodbye now.